It's episode number 12.
Yes, sir.
Episode number 12. We're back. We made it 12 episodes. Can you believe that, Peter?
Look, I got a mic
12
stand.
episodes.
I'm not going to respond to this again. I can't
Oh!
can't do it.
And on the 12th episode, you had to upgrade.
Yeah, right.
Welcome back to System Prompt. My name is Val,
And I'm Peter.
and we have a great episode for you guys today. We have this one we're tugging on our heartstrings with this one because we feel like we're covering all the stuff we love to talk about, and we're going to dive into it. We're talking about the future of AI workers. The future of AI workers. This is a dense one, but we're gonna stay with us for a little bit and allow us to take you on this journey, because we think the future of how we're gonna work with AI is gonna operate outside of just the agent. It's going to require a lot more than that. What are you thinking, Peter?
Yeah, and the really cool thing about today is that, this is my arena. But we're not talking about models. We're not talking about prompts today. We're not focused on agents. We're going to be talking about hardware, right? And for the last few years, the AI conversation has been dominated by model capability. Bigger models, smarter models, more context, more benchmarks. But now we're seeing an explosion of hardware that's specifically designed around AI workloads. I mean, everyone saw the announcement, right? That NVIDIA made over their GT. NVIDIA's building an AI native laptop and desktops, right? DGX stations to Windows, NVIDIA RTX Spark laptops, 128 gigabytes unified memory. AMD is shipping machines with enormous unified memory pools. Apple M5, 128 gigabyte unified memory pool. You got edge devices that are becoming powerful enough to run workloads on.
It's got me
Right?
thinking. It's got
Yeah.
me thinking. What's the big play here? It's almost like while we're looking in one direction, we probably should be focused on another direction. We're looking at models, we're looking at API costs, we're looking at the gloom and doom of AI taking over work, and how are we going to afford this, and is it taking over work, is it not? Are the job apocalypse, is it here, is it being canceled? When really, should we be looking at what's quietly happening, or maybe not so quietly happening, with the hardware being set up to really change how we work, because the hardware is bringing everything locally. The hardware is bringing our workload locally, is bringing our ability to manage agents locally. It's really bringing our ability to interact with AI locally. But even greater than that, is it replacing our traditional computers? Is it replacing laptops? Or is this the shift? And is it happening now?
Well, they have to buy them, you know, if you're an employee at a company, you're getting a device anyway. Why not it be an AI device? But first and foremost, we got to do the introduction, right? What are these devices? Let's dive in. Let's have a
Let's dive
conversation about
in.
them. Let's
Let's dive
do it,
in.
right? So first and foremost, now obviously because I own one, we're gonna have to start with it, and that's the NVIDIA DGX Spark, right? The current price right now, they did bring it up. It was released at about $4,000 per unit. It's now up to $4,699 per unit. It uses the Grace ARM CPU, Blackwell GPU, 128 gigabytes of unified memory, 10 gigabyte networking. I believe right now you can cluster up to 3 without a headache. If you do any more than that, you're on your own. Um, it isn't a gaming PC or a traditional workstation. And it's a data center that's on your desk. Now, what can you do with that? Well, for starters, you're getting the CUDA ecosystem, which is what models are trained on. So that's first and foremost, right? Remember, you're not just buying this machine for inference, you're buying the CUDA ecosystem. CUDA ecosystem lists for everything. It lists for speech to text, text to text to voice, model training, model fine tuning. Uh, it lives in the CUDA ecosystem. Are other ecosystems catching up? NVIDIA owns, I don't know, what is it, like 85% of the market space? It's somewhere obscene. But that's what
Yeah,
you're getting with this.
that's their ace in the hole right now.
It's yeah. And they just, uh and then they announce, the DGX Spark is this amazing tool. I run my own harnesses on it. This isn't going to be a conversation about me, but you can run up to 200 billion parameter models on it. They got playbooks that you can use right out of the gate, so you can really get to 0 to maybe like 50 or 60. I don't want to say 100, right? Because when you're using the playbooks, it doesn't you're basically using Happy Pass. And when you're using Happy Pass, you're going to get something working, but is it going to be exactly what you want? You're going to have to make you're going to have to make adjustments. You're going to have to make sure you're making the small tweaks to get exactly what you want. But it's an amazing device, right? I have maybe like 48 models on one device. I have a router. It can point to this model, can point to that model. If I'm just using something, let's say like text extraction, you could use something smaller, 4 billion parameter model to like a 14 billion parameter model. If you want something for reasoning, you could use the Gemma 4 or the Quen 3.6 models, which have been excellent, right? And these are something that they're really competing with some of the frontier models, but I don't want to detract. Let's focus on the actual device itself, right? The ease of setup. I mean, look, it uses an NVIDIA operating system, so it's basically Linux with an NVIDIA spin on it. Uh, the big
But
problem
when you
is,
say NVIDIA spin, you're talking about an agent first NVIDIA spin, or what are you talking about when you say NVIDIA spin?
well, specifically when I'm talking about NVIDIA spin, it's an operating system that NVIDIA worked up, right? So it's their, for lack of better words, Linux distribution system, right?
Okay.
It's their Linux distro. Uh, Now it doesn't have. What's interesting is that AI is not really. You would think that AI would be the center of it. It's not. It's literally just a Linux distro that's just it comes pre-stock, ready to go. It's got the CUDA drivers in there, ready to go. But it doesn't have any AI actually installed when you open it. When you open it out of the box, you're gonna have to go through. You're gonna have to understand the lowest hanging fruit. You start with, and this is going to be for all the devices. You're going to start with Olama. You'll go to VLLM. For the DGX Spark specifically and the Blackwell devices specifically, you have to try out TRT, right? You can't not. And then, okay, so it's this great device, right? What are the caveats? Well, it's not the best memory bandwidth. I think it's about 275 gigabytes a second, comparatively to some like the M3 Ultra. M3 Ultra, there's 800, right? So you're talking about a much small, but it is an AI processing machine, so your prefill is going to be fantastic. But here's some caveats. It wants to run an NVFP4 format, right? And that's a quantization. And now I know a lot of people out there are going to be like, I don't know what that means exactly. Okay, so you think of it like, okay, so you have regular models. FP16 is generally where things are ran. FP8 is good. FP4 is generally seen as not being that great. NVFP4 is not an official standard, it's an NVIDIA standard. So NVFP4 actually brings up precision and you're able to run things on FP4 with FP8 accuracy, right? So it's really good. It runs it really fast, but you're still going to sit there and struggle with it because it's not plug and play. You're sitting there and you're trying to run models on VLLM, on TRT, and you're just like, you can tear your hair out because you're still going to sit there and you're still going to fuss with it. You're still going to find you're going to be cruising, hugging face a lot to try to find some happy paths to get some models running in this format, just so you can see how it works. Olam is really like the lowest hanging fruit possible, but dense models are going to be significantly slower on a DGX Spark as comparative to like mixture of expert models. Mixture of expert models run with a portion of parameters. Let's say if you have a model that's 27 billion parameters, a mixture of expert model will only load 3.3 billion parameters per expert it pulls. So it's really it loads the entire model in memory, but it's only sourcing 3.3 billion parameter models for that specific question and answer pair, whatever. I'm trying to simplify this, and
Those are the
that
active parameters.
and those are the active parameters. So that's going to be it fills it super quickly. So you're going to be leaning towards your mixture of expert models, especially as it pertains to things that require speed. For things that don't require speed, you could wait a little bit more on processing time, some background jobs, what have you. You can use your dense models. Okay. How am I doing so far, Val? Am I?
Man, you're in your bag right now. This is you're in your wheelhouse, and yeah, you're covering the ground that needs to be covered, because I mean, we're setting the stage for what can be done, and then we're going to be covering why that's important. So no, you're cooking right now, man.
All right, cool. Just want to make sure because just what people need to have to actually understand what I'm saying, and sometimes I can really get lost in a lot of these terms, and then I love it, right? Because I live, eat, and breathe this stuff. I do it every day, and sometimes it's tough for me to realize that not everybody does it also, and it's like, wait a second, how do you not know what I'm saying? No, and I get all frustrated and annoyed about it. Anyway, so you have okay, so let's move on from DJX Spark. So just have an understanding that NVFP4 is not a mature enough ecosystem, and you're going to be waiting a little bit for that maturity to actually come through. But you're still buying the CUDA, ecosystem. That's pretty mature, but you're still it's still trying to, NVIDIA's still trying to figure it out a little bit with NVFP4 specifically. And then you move on to the announcement that they made, right? You got the NVIDIA RTX Spark laptops, 128 gigabytes unified memory, same as the Spark, AI first architecture, local agents, portable inference, right? This is your AI native laptops, as opposed to having a box on your desk.
That's where I feel like, if there was ever a direct strike against current architecture or the way things are done, this is like the first chess piece that's being moved, saying, "Hey, why don't, if we're using models and we're leveraging AI for everything we're doing, should that start at the device level as opposed to the cloud level?" Curious to see how this plays out.
Yeah, no, absolutely. But the one thing that I just wanna I wanna the NVIDIA RTX Spark laptops, a lot of people are like, "Oh my god, this is gonna change things. This is this is gonna be so impressive." But they weren't the first ones to strike. Apple was, right? So with the NVIDIA RTX Spark laptops, you're getting more of the same. You're getting the Blackwell GPU, you're getting the Grace ARM CPU, I don't know if it's Grace ARM, but you're getting an ARM CPU specifically in the Spark laptop. But you're still gonna have the you're still gonna be struggling a little bit with NVFP4 format, and you're still gonna be in that boat with the NVIDIA RTX Spark laptops. Okay, it's the
And
unified memory.
that's where Apple shines.
Yeah, especially when it comes to unified memory, right? Because they announced the M5, the MacBook Pro M5 Max, right? Up to 128 gigabytes unified memory, so it's the same as the other two. Strong local inference, and they're touting exceptional battery life, right? So you're talking about like an MLX is becoming like this legitimate ecosystem, and you compare it to CUDA, right? MLX and CUDA. So it's what they're building to rival the CUDA ecosystem. Would you rival the CUDA ecosystem? I mean, it's tough, right? If NVIDIA has 85% market share, how much market share do you think Apple is going to eat up? The problem with it is that Apple systems are very easy to get, right? Because all of them do unified memory across the board. So even if you're picking up a 16 gigabyte Mac Mini, you can run something on it, and that something could be a vision, could be could be a chatbot, could be a smaller model, could be an image generation model, could be a could be a video generation model. And it's kind of wild because that's kind of where Apple excels at anyway. But let me not detract. So you have MLX is becoming a legitimate ecosystem. One of the big problems with Apple before MLX really kind of pushed it in was concurrency, right? Because you weren't going to have good concurrency. Like you had great memory bandwidth in these Apple products, but you didn't have good AI processing. So it was the trade off, right? So you're buying the good AI processing with NVIDIA, you're buying the memory bandwidth with the Mac, but which one is the better trade off? Now, some people, right?
Yeah, I
So
mean, I guess I'm thinking, are they rounding the corner? Are they just getting to that point where the tools that they offer, the MLX system, are they there yet, or are they still a little? They're still a little, maybe a couple months out, maybe a year out,
I
or
want to
are
say
they rounding the corner?
a little bit longer than a couple of years. I want to say that they're rounding the corner, but the problem is that there's just such. It, it's one of those. It's more like a Grand Prix corner instead of like you're hitting the corner of the block where it's much longer. It's
Yeah.
you know what I mean. You have to actually finish that whole maneuver. But it is going to be something where Apple didn't focus on models specifically; they focused on hardware. So they made some really good decisions to move into that. One of the really questionable decisions that I saw that they did, and it's probably attached specifically to the cost of memory, is that they moved away from their 512 gigabyte unified memory systems. The last one is the M3, right? And that was on launch. They're not making them anymore. There's no more of those being made. So if you have one, congratulations. You have two of them, you can run a Kimi K locally from your lab, clustering together with Thunderbolt, right? Because you can do that with the Apple systems also. Cluster using Thunderbolt. We can talk about clustering towards the end, maybe not. That's a whole conversation in and of itself. But I really questioned why they did that and why they're not making it. It's probably because of price, whatever. But people will buy it. People were eating them up. Like you cannot find a Mac Studio Ultra anywhere anymore. They're rounding the corner when it comes to concurrency, which is good, but I still don't think they're there yet, right? Because that's one of the problems with a lot of these devices is you have to think of them as almost like personal or very small team appliances, right? So you're not
Three
going to
to four
have,
people.
uh, depending on the use case specifically, right?
Okay.
Depends on how much processing that you're putting through it, but you can do a small team. You can do any more than that. You're gonna start running into issues. Uh, is MLX good? It's equal to it's still a little bit behind like NVFP4. You can find some models that are really good. Any new models are coming out with MLX variants as well. So you're really getting the ecosystem. It's getting there. Where once upon a time, people wouldn't take you seriously if you were just buying Mac Minis or Mac products to do this because they would say that you were just a tinkerer or something, right? Um, and now these things are becoming more and more standard. Uh, really, the difference is from when you have a discrete GPU, your processing power is going to be much faster because you have a discrete GPU. But that's
So what's the cost trade off with the Mac compared to like a NVIDIA?
so right now, specifically with the M5, I don't know exactly how much they're going to be costing. I imagine they're going to probably be in the same range as a DGX Spark or the NVIDIA RTX. The NVIDIA RTX laptops, I believe, don't have a price just yet either because neither of them are just yet released. But you can pick up like a 24 gigabyte Mac Mini for about $1,000 right now,
Okay.
which isn't the greatest when you're comparing it to 128 gigabyte unified memory system as like a DGX Spark, because those prices are also going up. It used to be 700, but even why buy something under 128 gigabytes unified memory at this point unless you're running a really small tiny workload or you're just kind of tinkering or you're using it for some sort of edge devices. I mean, cost wise, look, if you don't have the money for it, I'm not trying to attack anybody here, right? It doesn't have the money for a device. But if you're talking about using this for a small team, or if we're talking about in terms of replacing laptops, right, for an employee, right? If you're spending $1,000 on something that can't really handle very much, or you're spending $4,000 on something that these people can go and create their entire workflows using some of these AI agents. It's a different kind of conversation, and then you really have to bring up how much are they going to cost in AI token spend throughout the course of the lifetime of their employment, and can you instead of that token spend Can you can you turn that into a single device cost, right?
Well, this is where my mind is going, you know, and this is what I'm really thinking, because the talk of the town right now are people blowing through their token budgets, their yearly token budgets in the first quarter. So yeah, for the individual, obviously, if you're a hobbyist, you know, that's a completely different scenario. But if we're talking about a small business, 100-person team that is already all in on leveraging AI. Is this an alternative to spending tens, if not hundreds of thousands of dollars in API fees, with all the other added benefits? But and there's options. You know, we already covered 3. There's a couple more. Let's go through them and let's see. Let's set up a use case for a mid-sized business. Let's run through these other devices, and let's see if we could come up with something, because the wheels are turning right now.
Yeah, of course. And next you have like you have the two AMD products. You have like the Strix Halo with the framework desktop, and then you have the Gorgon Halo, right? AMD Strix Halo framework desktops are half the price of your Apple and your NVIDIA counterparts. Same memory, pretty much the same memory capacity. Um, they're touting AMD as being the most disruptive player in the room right now because they're not charging the same as anybody else is. Uh, what is the problem with AMD? All right. So you have MLX, which is a booming ecosystem that people are really driving that forward. They really want the Apple ecosystem to work. You have CUDA, which is 85% of the AI ecosystem, period. So you know what you're getting with NVIDIA. What are you getting with AMD? You're getting ROCm.
Not
Consumer side,
Rock'em Robots,
yeah,
Rock'em.
ROCM, right? That's the ecosystem you're buying into, and you're getting AMD. Now, I don't know if you've ever owned an AMD video card, but if you've ever owned an AMD video card and tried to install drivers, it's not the cleanest thing in the world. And this is years ahead of when they're being competitive. Do you think it's going to be any easier trying to do anything except inference on their devices? That's that's my biggest problem with AMD. And I know all the AMD fanboys are gonna be like, "Yeah, you're licking NVIDIA's boots. You're licking NVIDIA's boots. I'm buying a fucking ecosystem that's already created. That's the decision I made. You want to buy ROCm and wait for them to actually build out an ecosystem for it? That's fine. Where the AMD ecosystem, where it thrives, if you don't have to do fine tuning, you're not doing a lot of AI engineering work in terms of model work. You're just hosting inference, right? So and that's a perfectly legitimate way to use it because chances are the models that you're looking for are fine tuned in the way and they're already available on Hugging Face. So you don't have to put in a lot of that work, right? Now, if you have specific edge cases or specific use cases that you need to fine tune for, you're going to struggle with it. You're going to struggle with it because that's not what AMD is great at. That's not what they're great at. But they're really good at hosting inference. So half the cost, but you feel it in the tooling,
Okay. All
right?
right. Yeah. No, I'm doing my back of the envelope math right now,
Yeah.
and I'm coming up with a strong argument for, you know, I'm thinking if you're a 100-person company, 20% of your team is doing agentic coding, and then the other 80% are, you know, they're running agent workflows. Um, and you're concerned about rising API costs to manage that. The conversation is, well, you know, we let go these people, um, and we're replacing them with API costs, which is an episode we actually covered already. And
Yeah.
what we thought would happen happened. You know, we were watching it right before our eyes, and it's going to continue to happen. Now, part of that reason is that we think that a lot of these workflows are not optimized. The harnesses that are being used to manage these agents are just they're out of the box or none at all. And people are using frontier models for tasks that very small models can outperform in many ways, at least on cost. So I'm thinking about it. I'm saying, hey, if you're a 100-person company, you know, there was an article I read from LinkedIn, where they went all in on a something called the Associate Builders Program, where LinkedIn is saying, hey, we believe the future of of software development is going to be in small teams, 3 to 4 people. You got a project manager, you have a UX UI person, you have a software engineer, maybe a security person, maybe 3 to 4 people. They believe that small group of people with agents can ship features and code and software and applications much more quickly and efficiently than the counterpart of maybe 20 to 30 people, whatever those numbers may be. And they're all in on it. They're training people as we speak. I, the numbers were much larger than I thought justified at the time. But now I'm looking at it and I'm saying, hey, okay, if you're a company and this model works and you have 3 to 4 people and you have something like a framework and you create a harness that can optimize local models and frontier models for the appropriate tasks, is this the future? Is it, if you're a company and you're committed to buying hardware, should this be on the Christmas list?
I mean, I don't see how it can't be, right? Because we, if you don't see the writing on the wall, everything is getting pushed towards metered inference. Everything is going to get pushed towards metered inference. You use Copilot and Agent Studio, you're doing per usage basis. You're doing most coding tools outside of like Codex and Claude Code right now. You're doing metered inference, and eventually everything is going to be pushed into metered inference, and you're going to be paying per usage, right? And and if you're in a situation where you're accustomed to being subsidized, your costs are going to balloon and they're going to explode when that happens, because you're going to try to maintain the same kind of admin workflow that you're using or that you're accustomed to, and it's just not going to be able to handle that, right? You know, and I mean, look, a framework we know is half the price of a DGX Spark, right? But let's say you have one development team that has one DGX Spark, and all they do is fine tune. They work on the fine tuning the models that get rolled out using framework, right? So, and then the people can just pick up the models from there. So that way, you're using the CUDA tooling the way it's supposed to be used, and then you're punting it over for the AMD devices for just straight inference, which is what's happening at hyperscalers anyway, because that's what they're buying AMD for.
Even as you say that, I'm like, well, sounds like you just created some new roles, you know,
Yeah.
where who's going to come in and actually set up these devices for a company? Well, that person didn't exist 5 years ago, but somebody that comes in and understands how to, because this is the big conversation. Well, some of these need to be set up properly. Well, yes, they do. And you're going to hire somebody that knows how to do it properly. And when you start to crunch the numbers, you're saying, hey, our API costs don't have to balloon. Does it mean we throw away the frontier models? Absolutely not. They're great, but they're not necessary for every single task. And for a lot of the companies that are, if you're running research and you're using you're leveraging agents for various tasks, routing to the proper model is the future for cost, energy, you name it. It's how we haven't even discussed security, um, um, uh, um, um, uh, personal information, PII, not getting out to these trained models, keeping everything in house. These are all the conversations that, if they're not being had yet, will be had, and they all are solved with this one solution. Get get a local device. You have a team of 3 or 4 people. They're leveraging a local device. You have a couple DGX Sparks there for the people that can train these models, and now you're optimizing your workflow for a team, um, who can leverage these agents locally and only tap into the frontier when absolutely necessary. So if the model price for frontier goes down over time, great, it's cool, you win. If it goes up, you're prepared. You paid once, and probably in 1 year you'll see that savings. But we're talking 2 or 3 years. Come on, it's a no-brainer.
Yeah. It's and then you have a lot of people who are going to sit there and they're going to have the conversation with you and they're going to be like, oh, you have to go cloud. You have to go cloud. Like if you want privacy, why don't you just go AWS Bedrock? Why don't you use Azure Foundry? But it's the same thing because you're still paying for inference. You're still paying for hosted infrastructure. You're still paying the metered cost. So, I mean, look, it's dependent on the business. It's dependent on the budget, right? But if you're going to have AI running continuously in the background and it's going to be chewing up costs, right? You need routing. At the bare minimum, you need to have an understanding that you're not going to be using frontier reasoning models for every task.
Bare
Bare
minimum.
minimum.
Bare
Yeah,
minimum.
yeah.
Bare
So,
minimum.
right,
And if you do, we run a show called System Prompt. You can just give us the money because that's what you're doing. You're burning it. Might as well give it to us if you're the company out there using a frontier model for absolutely every single task.
just call us. We'll show you how it's done. I mean,
Yeah.
we'll come in. We'll fix it for you. This is what I do. Uh, I set up routing. I set up specialists. I use local. I use hybrid. I use frontier. This is literally what we do. But you're absolutely correct, especially when it comes to PII. Now, imagine you have a DGX Spark, or you have a framework computer, or you have the Mac Studio, or whatever would have you, and all your inference goes through a gateway. Because again, I've said this a few times. If you're sending anything, please stop making direct API calls. Put it through a gateway. They exist. There's so many that exist. If you need one, just contact me. I open source one. It's on GitHub. It just
Yeah.
to point you in the right direction. Please use the gateway. You need observability. If you're just sending inference to an API, you have no idea what's happening. It's a black box for you. But what you do is you can set up a model that's going to look at whatever you sent, scrub any PII, and then continue sending it. And does it cost some latency and some little bit of overhead? Yes, but what's the alternative? You're sending PII to third party providers that you don't control the data of, and that's a liability. I mean, look, we had Joe Ewing on last week, who we said we have to, and we didn't talk about him this week. He was a great guest. I had a lot of fun with him.
Yeah.
But what
No,
was the most
no,
important? Yeah.
great conversation with Joe, man.
But if anything stuck with us in that conversation, it's move fast responsibly.
Yeah.
Move fast responsibly. And you're going to see it. I'm already having conversations with business owners that are like, I'm super scared of API costs. I'm super scared of being caught and being completely dependent on these frontier models to do these tasks. And what can I do? What's your budget? Is always my next question. What's your budget? And they tell me their budget, and I start with a DGX Spark, start with a framework desktop. You don't need to don't go out and buy a rack, right? Buy something that your developers can sit there and tool with, and then when they're ready, they roll it out, right?
Well, I mean, you bring something interesting. You just kind of sprinkled it in there. I mean, does this concept also work at scale? Now let's take a step back and say you're a 15,000 person company. You have 15,000 employees that are cranking away at these models every single day. At what point in time does it make sense to go in and look at a Blackwell?
Yeah.
Sounds very expensive, but when you really start to look at it, okay, you get a Blackwell for 2 to 3 million. I'm not saying that is cheap, but we'll say 2 to 3 million. Maybe cost 200 grand in energy costs. Probably have to get a server engineer in there somewhere. But at what point in time, if you're a company of that size, would it make sense to invest in that in the long term for all the reasons that we just talked about? In addition to API costs, you can still route when needed, but you could host some models internally. It could do a lot of the heavy lifting. Security is still there. If you have internal processes that you don't want exposed to the world, keep that thing tight. Personal information, you're in control of it. Internal workflows, all of these, none of these concerns are concerns anymore. Does that make sense at scale too? What are your thoughts?
Well, let's do the math. Let's do the math right now. You're talking about a 15,000 person company. Chances are they going with Microsoft, right? They have Microsoft. So let's assume Copilot. Copilot, a seat is $30 a seat right now, right? That's just for the chat function. That's not building agents. So if you want to just chat with somebody in your Word document in your Excel, or chat with a large language model, $30 per seat, 15,000 company per month. I got the calculator. $450,000 per month.
Oof.
Per year, that's 5.4 million. And this is without metered costs. This is just a seat. This is just for a chat bot for your for your
I
company.
mean, it sounded crazy, but if everybody's moving towards what the future is, which is leveraging AI, not replacing a bunch of people with AI, but leveraging AI agents to maximize output, at what point in time, if you're on the C-suite, do you start to say, hey, if this is the direction we're going in, these numbers sounded crazy before, but maybe they start to sound a little bit more reasonable if we really start to crunch them. We we get a Blackwell. You know the upfront cost is going to be heavy, but after 2 years, you start to look at uh, uh, the overall cost, and you're saying, hey, we saved $4 million taking this quote unquote gamble.
Yeah. I mean, look, it takes a while for you to get that back because you can't go out and buy DGX Sparks for 15,000 people at $60 million. That's the trade-off,
Yeah,
right? But buying a Blackwell rack is going to be like 2-3 million. How many concurrent users does that store? It really depends on your usage. Uh, Look, it's very dependent. That $30 seat for a chatbot and that $5.4 million a year might be what you need in order to give everybody a chatbot in your company, right? Somebody that they can just have a conversation with. The interesting parts of it is when you start creating these automated workflows and you start creating these agents to go do things, and then those are actually metered spend as opposed to monthly spend, what is that actually costing you? How much are you using it? What is it running 24 hours a day inference? And what pipelines are you setting up for it? What harness are you using for it? And then it, when you're asking yourself those questions and you're actually pulling the curtain back and you're like, okay, what does that cost me? And then it starts
yeah,
to make more sense to have maybe some of this infrastructure in place to do those things. Do you need to, if you're a 15,000 person company, do you need to buy a device for 15,000 people? The answer to that question is going to be usually it's going to be no,
yeah,
right?
yeah.
It's going to be no. But can you buy one per department? Can you buy a rack for the entire business? Or can you, or do you specifically only set up the tasks that you need it to do as background processes for your business to continue running? What does it actually look like? What kind of concurrency do you need? Those are all questions that you can answer depending on what your use cases are. Uh, and I
In
don't want to talk. Yeah,
one way or
go ahead.
another, the conversation need to be had. It's either that or you're gonna be beholden to these model providers. And we hope that it's gonna get cheaper over time, and it should. But what is over time? Is it next year? Is it the next 5 years? Is it the next 7 years? What does it? The conversations need to be had now, and and the numbers need to start to be crunched. And as we're talking the whole time, I'm like, well, this is where the new jobs come in. These are where who are the people who have expertise in the space that could come in and say, hey, this is how it looks, or this is how it can look. These are the trade-offs. This is your workflow, and this is how it could be optimized. At the very least, there should definitely be some sort of routing in place to make sure that you're using the right model for the right task. And I think you may have heard it here, here first, folks. Uh,
these things are just going to become more and more popular. They're going to get cheaper and cheaper, and that's the way tech works, right? We've seen this. We've seen this cycle many times. And you know, let's say we take that same 15,000 company, and we'll just end it on this note, right? 15,000 company. Let's assume there's like the development people only get DGX Spark, so we're not gonna use them in the cost, but just to build models. Let's just assume 15,000 company, all buying framework desktops. That's one for every 4 people. That's a $10 million cost. It means you recoup the cost of your you recoup the cost of your purchase in 3 years.
It's conversations that need to be, you know, these are real conversations, you know.
Yeah.
These are real conversations when you really balance everything. You know, these are real conversations, and you heard it here first.
Yeah, of course, and then we're gonna get killed because somebody's gonna be like, "Depreciation, depreciation," and, oh.
Yeah, capex. Yeah, yeah.
Come on, and they're gonna be like, "Oh, you didn't even cover the rest of the quantizations. This wasn't that kind of episode. You really want me just to go into FP32, FP16, FP8, FP4, Q4, Q2, Q1? I'm not gonna go into all of that, but let inference, it's interesting because the cost of inference is going down, but the capability is pinned up. Let's end this on what we're actually seeing, right? Frontier labs are very cyclical. The cost of Opus 4.5 is down. The cost of Opus 4.8 is up. They're pinning us at higher capability and costing us more so they can why? So they can justify the cost of the AI data centers that they're trying to build. So they can justify all they have to. They're stuck. They need money to continue flowing in. They can't host the the lesser models, so they're pinning us at higher models, which are higher cost.
Yeah, I think, yeah, I think that's a good place to end it. But this was such a great conversation. We may have to do a part two. We may have to do a part two and dive a little deeper.
And somebody got on me and they said that I wasn't asking people to like and subscribe. So I'm gonna do that now, and I'm gonna go, hey, like and subscribe.
We're 12 episodes in. We're 12 episodes in. We're maybe a little late to the party, but you are 100% correct. You found anything that we've said valuable over the last 12 episodes, um, do us a favor. Like, share, comment, and subscribe.
See, this is why I keep Val around. He's the smooth one. Uh, uh, Look, guys, it was great. Thank you so much for coming. We'll see you guys next week.
Take care.